Hey guys, this is Harold with another application design. This time, this application is AutoCyber Log Editor. At a high level, it's a text editor designed around how engineers and analysts actually work with large, messy diagnostic logs in the automotive and cybersecurity space. Instead of just typing like a normal notepad, this tool is built to help someone quickly understand what's going wrong, spot problems faster, and reduce human error when reviewing logs. Everything you see here, from the layout to the highlighting to the way information surfaced, was designed around a simple idea. Software should reduce cognitive load, not add to it. I'm going to walk through a few features to show how this editor supports the mindset. First thing I'm going to do is load a file. Now, this is a test file. So it's going to allow me to pull out relevant information. But the same way we pull out information from this test file is the same way it could be used to go through a live document or a live system log. So now I have my document or log, and what you would see, the first thing we could do here is the search feature. So what we come here and let's do find. And first thing we're gonna look for is search, and then pulls up the search. Then I'm gonna control Z to unhighlight. The next feature I'm gonna show is to replace. And what I'm gonna replace is search me with found me. Search me. I'm gonna replace that with found me. And I did something wrong. Let's try that one more time. So replace, and this is gonna be, so search me, I got right. All right. So we're gonna replace with found me. Make sure I got that right also. And that should work. There we go. I must have spelled something wrong. So this was search me, now it's replaced with found me. Um, Next feature is go to line, and we could choose line 20, and it brings it right here to the top of the line. Then we're gonna move on to the view. We can start from the top, work our way down. So this feature, log triage, what this feature pretty much does is it goes directly to um, where the issue, where you may have in the past say, okay, we when we see this string of information or this hex number, or whatever type of communication, sentence, words, whatever you're looking for that you have noticed, this is set up where it would target it. So in my field, a lot of times people would put in, um, they would put in new control units or attach something to the vehicle and not program it, or aftermarket component, and um, and then not be able to programming or have all types of communication issues. So for this example, I have 27 or mode 27 set up, So what this would do, it will filter for all your security access issues, which you see here. And then we will release it by just clicking on it again. But this could be set up for any issues in your industry or in your field to filter directly for, so you don't have to, filter through and read through everything. The next feature is highlight similar text. Uh, I do not have that implemented. I forgot. Dark mode. I like to have my systems in dark mode, so I had to put it here. The dark mode, and to come out of dark mode, we just click on it again. The next, this feature, or these features are my favorite features, because it's a lot of times I'm reading certain strings of information, and it bounces from UDS to hex to ASCII, or from ASCII um, to hex. So this feature was my favorite feature. So let's start with decoding UDS, and we're gonna start here. And we don't have to go to the toolbar. We could just right click, and we can say decode UDS, and it would decode diagnostics session control. I'm just gonna do a few. Uh, this decodes read data byte identifier, and just one more. Security access. I'm gonna move down to, now this is hex to ASCII, and we come here, hex to ASCII, and it says hello. Converts it. Same thing here. Should say test. Tells you exactly what's going on. In addition to that, this one right here, like even if you have items that is not part of the protocol, it would ignore, like these braces and things like that. It will still decode. So you come here, and it still decodes. Um, if it's the wrong protocol, it won't. It would just give dots. Uh, yeah. Moving on to ASCII to hex. So AutoCyber will convert to hex, and this will also he will convert to hex also. And you could also, if you click yes, it would change it. And you just hit Control Z, and it changes it back. Uh, we already did this test. Words, it does wrap. So if these are too long, you can't see them. Um, it will also remove or apply. So now, so now you see how it goes to the end and then comes back over here. So if let's say, So if I make the screen shorter, it won't keep wrapping. And we just come down to the next line. And this is my editor. Um, this is my editor for the automotive, cybersecurity, engineering industry. Uh, Now what I'm going to do is I'm going to speak on my code. So I'm going to close this. All right, I'm going to close this and I'm going to speak on my code. Give me a moment to get it set up. I'm going to start from the top. What I want to share here isn't how to write code, is how I think about solving problems in the automotive and cybersecurity space. Modern vehicles generate massive amounts of diagnostic data. Engineers, analysts, and technicians are expected to make fast decisions from the data, often under massive pressure. This application is my way of exploring how software can reduce cognitive load, surface risks early, and support human decision making rather than replace it. So the first line that I'm going to speak on is line 50. So I'm just going to come down here and speak on this line right here, line 50. Make sure I'm on the right line. Yeah. Okay, so this line right here, it highlights uh, it highlights in triage mode. Uh, I actually forgot to show you guys something. Let me just reload this. Give me a moment, because this is something that was relevant also. Let me just reload this, bring this over. I'm gonna grab that document again. And what we can do is, so let's say we highlight this, we can highlight this, highlight this. We can highlight multiple lines of information. So we don't have to so regular text editor only allows you to highlight one line at a time. But when you're trying to go through massive documents, and you see points of failure that you're trying to correlate, this feature is like awesome. And then, so yeah, I wanted to show you that, and then I can remove the lines. I didn't think about that until I seen this right here. So this is the triage mode section. In the real world, logs are not read line by line. They're triaged. An engineer isn't looking for everything. They're looking for signals that indicate risk, failure, or security relevant behavior. This part of the system exists to model that reality. The software is designed to recognize known failure indicators automatically, the same way a human expert would scan for them mentally. This isn't automation replacing expertise, it's automation supporting expertise. This is what this section does. The next section I want to speak about is line 81. Uh, this line of code. So dealing with this line of code, this deals with representing user mark lines. One thing I'm very intentional about is not assuming the software knows more than the human. Automated systems are good at pattern recognition, but engineers still need the ability to flag, revisit, and reason about information manually. This feature allows a human to mark lines that matter that matter to them, regardless of what the system thinks is important. From a industry perspective, this supports accountability, traceability, and collaborative review. This is awesome. The next line of code I want to speak about, we're going to go all the way down to 1575. 1575, which is here. Let's start here. In safety critical industries, usability is not cosmetic, it's functional. If a tool flickers, jumps, or behaves unpredictably, it increases cognitive load and error risk. This part of the design ensures that visual updates happen cleanly and deliberately. The user's focus is never disrupted. The software adapts to the user, not the other way around. So um, here, this begins the update. It tells the window not to repaint until an end update is called. And the end actually happens on line 1620. I'm gonna go to 1620. So this is where it ends. So the next line of importance is line, we're gonna go back up to 574. 574. Okay, so you're seeing that I spoke about this in the application. So vehicle systems communicate in low-level codes that aren't meant for humans. One of the biggest industry gaps is translation, turning raw machine data into uh, meaning that can be acted on quickly. Instead of asking engineers to memorize protocols, the system interprets these codes into plain language. This bridges the gap between embedded system, cybersecurity, and operational decision making. So these explain this to you real quick. So these are standard codes from ISO, uh, which deals with UDS protocols. And these are just some of the artifacts that stands out, but this could be added to depending on your industry or what stands out to you when you're analyzing logs and triaging alerts. From a research perspective, this project is a foundation. It raises questions like how do we prioritize signals in high volume vehicle telemetry? How can software support expert reasoning instead of overwhelming it? Where should automation stop and human judgment take over? These are the same questions that appear in safety engineering, cybersecurity, and autonomous system research. A future research direction could involve adaptive triage models, behavior analysts on diagnostic sessions, or AI assisted log interpretation, always with the human remaining in the loop. In closing, this application represents how I approach engineering problems. Uh, start with industry realities, design around human decision making, and build systems that scale towards research and long-term impact, whether in industry or academia. That mindset stays the same. Thank you for watching another video.